All right, we're going to look at some algebraic fractions. First thing we're going to look at on the algebraic fractions is simplifying them. Now, there's some rules to simplifying algebraic fractions. You could cancel terms only when we are multiplying. So I have 5 examples here on the board. There's some of them where we would be able to cancel and some that we would not be able to cancel, right? So let's take a look at them. In this first one, we have 2x over 4x squared. Notice that there's no addition signs between this 2x and this 4x. Everything is all multiplication. In instances like this, just like with fractions, we could reduce, right? So I could simply say 2 into 2 here will give me 1, 2 into 4 here will give me 2. I could also cancel the letters. So I have 1x here and x squared, you know, is x by x. So if I cancel one of the x's here with one of the x's from underneath here, I'll remain with the x. So my answer, no problem. My answer will be 1 over 2x. This is another one where we have brackets on top of here. So we are multiplying p minus q by p plus q. So because this is a bracket here and you're multiplying, I could actually cancel this entire thing with this entire thing underneath it. And I will get p minus q over 1. Because we get a 1 and a 1 here, which is p minus q. Now look at this one. This one is a bit different, and this is what I'm talking about. If I expand this bracket, I'll get 3a plus 3b. There's a misconception that we could cancel the 3 and the 6 here, or the a and the a here, and the b and the b there. That is incorrect. The reason that is incorrect is because this is treated as an entire term on top. I can only cancel if I have the exact thing at the bottom to cancel. For example, look at this one. If I look at 3a minus 6b, and underneath here I look at 5a minus 10b, we could actually factorize on top, right? 3 and 6 have a common factor, which is 3. If I factor the 3 out, I remain with a minus 2b. Similarly, underneath here, if I factor the 5 out, I'll get a minus 2b. Unlike this one here, number 3, we have an entire bracket that is the same. And this is being multiplied by 3 and 5. So we can cancel in an instance like that. And we will get 3 over 5. Here's another example. Here we have 3ab. Yeah? Underneath here, we could pull out b. And we will get, sorry, I'm going to write this different. 3ab on top, and I could pull out b is the common factor between these two. A b here, a b there. So I'll remain with a plus b. Because I'm multiplying b by this bracket here, and b is multiplied by 3a here, I could actually cancel the b's. Unlike here, where we had b being part of an entire expression on top. So my answer here will be 3a over a plus b. Is everybody okay with that? All right, let's take a look at this. So here we could cancel. If I cancel in here, we could cancel this way. 1, 2. P's could cancel, and I remain with it's p squared, right? Sorry, maybe it's a p on top. So pq over 2. Now thumbs up if you got that. Here, this entire thing could cancel because we multiplying. So again, 1 over x. Here, we can't cancel unless we do minus 1 by... Oh, actually, yeah, we could cancel it. Because this and this is the same. Seen it? This and this is exactly the same, and we're multiplying it. So we could cancel. And I'll get 1 over v. Here we could cancel the 10 and the 15. We get 2 and 3 here. I can't do anything with this a because the a is inside of the bracket. So I'll get 2a over 3 into a minus b. And that'll be a final answer. Here, only if we factorize the bottom, we could cancel. Here, I could factor the 2, and I'll get 4a minus b. And then I could cancel this with this. I'll get 2 there, I'll get 1 here, and that's 2a over 4a minus b. Can't do anything further there. Underneath here, if I factor the bottom, then I'll be able to cancel. Right, so here I could pull out 3y, and I will get, what I'll get underneath here? I'll get 2x plus y, and now this and this is the same, and I can cancel that. I'll get 1 over 3y. Yeah? Let's look at these 3 examples of adding and subtracting algebraic fractions. So we treat algebraic fractions. Notice that notice here that for each of them, we don't have the equal sign that we saw before where we eliminated denominators when we were solving equations involving fractions. Here we treat all of these just as we would regular fractions. So you have to find a common denominator. Right? So I'm going to show you how to find the common denominator in all of them. My common denominator here is going to be x, right? This is like you have the same denominator. So we could keep the denominator and add on top 2 plus 3 is going to give me 5 over x. Yeah? So we're good with this one. Same denominator, keep the denominator, add on top. Give me a thumbs up. Different denominators. What do we do when we have different denominators? If we were adding a quarter, or we had a quarter minus a third, right? Should be the next way around. A third minus a quarter. I put this way instead. We will find our common denominator, which should be 12. Right? 3 into 12 will give me 4 multiplied by my numerator here. Bring down my minus sign. 4 into 12 will give me 3 by my numerator up here. See that? We'll come back to this. On this side, this is the confusing one. You need the LCM for each number and every letter. So the lowest common multiple of 3 and 4 is going to be 12. We have to have a x and we have to have a y. So every letter have to be represented in this LCM. So 3x into 12xy, 3 into 12 will give me 4. X into x will cancel and I remain with a y. We will then multiply that by the numerator, 6 plus x. Bring down my plus here. 4 into 12 will give me 3. X into x will cancel, y into y will cancel, and I'll just have to multiply 3 by x plus 1. Everybody understand that? After we do that, we back to our first thing that we looked at in the workshop, which was expanding brackets. So I could expand these out like this. 4 by x, 4 by 1, negative 3 by x, negative 3 by 3. 4y by 6, 4y by x, positive 3 by x, positive 3 by 1. So we're going to get 4x plus 4 minus 3x. A minus by plus will give me a minus. 3 by 3 give me a 9. 4y by 6 here will give me 24y. 4y by x will give me plus 4xy. I take any plus here because both of them positive. Plus 3 by x will give me plus 3x. See where the plus coming from? Plus by plus will give me plus. 3 by 1 will give me 3. See that? Put back my denominator. Put back my denominator. And then, just like we was doing with simplification, we group them up together like that. So 4x minus 3x will give me x. 4 minus 99 is bigger, so I get minus 5 over 12. Here we're going to get 24y with nothing else to add to that, so that's staying as is. We don't have any common terms here. Everybody's staying just as it is. See that? Same thing. Now we can't cancel, right? Because everything is a expression up on top. Cool. That's from easy to most difficult. Ready, right to that? 2x over x plus 1 multiplied by 3 over x. You could look for opportunities to cancel. So you could only cancel diagonally or up and down, right? But we can't cancel expressions like this. We can't just take an x out of it. We could do this x and this x. So we will get 2 by 3 and 1 by x plus 1. Right, this will give us 6 over x plus 1. Yeah? Everybody right to that? So we combine in the look for another example to look at. Look at this one. We have opportunities to cancel here. But before we do that, we need to look at this one here. This can be factorized. We have x squared minus 4, which is the difference of two squares. We could write this as x plus 2 by x minus 2 multiplied by 6 over x plus 2. This is going to give us the opportunity to cancel this with this with this. And we will get by 2 over 1. Write it like this. Or we could even expand it out as 2x minus. One more example. Let's say we want to divide. We know how to divide fractions, don't we? If we have 3s over t divided by 1 over 6st, we need to change this division sign to a multiplication and flip our fraction like this. Because everything is being multiplied here, we could cancel the t like that. We'll get 1. And then we'll end up with 3s multiplied by 6s over 1. 3 by 6 is going to give me 18. And s by s will give me s squared. Yeah?